5.5 factor quadratic expressions of this form, ax squared plus bx plus c. So we're gonna focus on complex trinomials. Complex trinomials is any trinomial in this form where the coefficient a does not equal 1. Okay, so a does not equal 1. So here are three examples. We see that the a value in this term or this expression is 4, the a value in this expression is 3, and the a value in this expression is -8. So these are definitely not coefficient 1. Okay, so what we're going to do is we're going to do the same thing as we did last time. We're going to do decomposition, but the thing is, at the end of the decomposition, there's not going to be an actual like shorter way or short form way of doing it. Okay, so we're going to take a look at two numbers that multiply to AC this time and add to B. Okay, we're going to rewrite that middle term with the two terms that we found in step 1, and then we're going to factor by grouping. So let's go ahead and do that. Okay, so let's factor. So taking a look at this, we have 2, 9, and 10. Okay, coefficient is not 1. So what we're going to do is we're going to find a number that multiplies to 20. So 2 times 10, okay, instead of just 10. And then still adds to that middle number. Okay, so I get 1, 22, 10, 4, 5. Okay, 4 and 5 add to 9. So what we're going to do is we're going to rewrite this entire expression, but we're just going to make look a little different. So instead of writing 9x, we're going to write 4x plus 5x, which is equivalent. So we're just rewriting the equation. It just looks different. Okay? We're going to factor by grouping. So we're going to group the first two terms and then the last two terms. So out of the first two terms, we can pull out a 2x. And if you have to formally do this, go ahead and divide each term by 2x. We're left with x plus 2. Okay, and out of the last two terms, we can divide out just to 5. So plus 5. And then we're left with x plus 2. And then we factor by grouping again. This is our first term. This is our second term. What is identical in the two terms? Well, the x plus 2 is identical. And then we're left with 2x plus 5. Okay, that's fully factored. Now let's try B. So instead of multiplying to 10, because the leading coefficient, the a value, is 3, we have to find two numbers that multiply to 30 and add to 17. So 1 and 30, 2 and 15, 3 and 10. Well, I can stop there. We have like 5 and 6 as well. But 2 and 15 add to 17. So we're just going to rewrite this a little bit differently. Keep the first term and keep the last term. But we're going to decompose that middle term into two terms. So let's do 2x plus 15x. Now we factor by grouping. I said x, I mean y. These are y's. Okay, out of the first two terms, we can only pull out a y. So formally, we're dividing by y. So we're going to have y bracket 3y plus 2. Out of the second two terms, we can factor out a 5. So positive 5, and then in brackets, 3y plus 2. And that's how you know if you did this correctly, because this term and this term are going to have a common factor. In this case, the common factor is 3y plus 2. And then we have y plus 5 left over. And this is fully factored. Okay, next one. The coefficient here, the leading coefficient here is 7. So the a value is 7. So we actually do 7 times 2, which is 14. So we have to find two numbers that multiply to 14 and add to -9. So I start listing factors of 14. 1, 14, 2, 7. Well, 2, 7 works. So let's replace this negative 9x with a negative 2 and a negative 7. Okay? So 7x squared, let's go minus 7x minus 2x plus 2. You see what I did right there? I recognize that this number here is 7, so I kind of wanted to group the 7s together because we know that we can factor out the 7. And then I grouped the 2's together because we know we can factor out the 2. So let's go ahead and factor out 7x from the first. So we get 7x bracket x minus 1. And out of the second two terms, we can factor out a negative 2. Just remember, if this term is negative, always factor out that negative. So negative 2, and we're left with x minus 1. Okay, again, we have two terms. Our common factor here is x minus 1, and we're left with 7x minus 2. Okay, last one. 3x squared plus 7xy minus 6y squared. I like these ones. They're a little bit harder because they have that extra variable. So what two numbers multiply to negative 18 and add to 7? So 118, 29. 29 looks pretty good. And let's put a negative sign on the 2, because then it adds to positive 7. So in this case, because this middle term is 7xy, we have to keep all of the variables. It's going to be minus 2xy plus 9xy, okay, and then minus 6y squared. Okay, now let's factor by grouping. Here are our two groupings. So what can we divide by? Here, we can only divide by x. And we're left with 3x minus 2y. And here we can divide by 3y. So plus 3y. And we're left with 3x minus 2y. Okay, these two brackets right here are identical, so that's going to be our common factor, 3x minus 2y. And then we're left with x and positive 3y. X plus 3y. Okay, these two questions just add one extra step. So whenever we're factoring, it doesn't matter what we're factoring, we always want to start by common factoring. So remove the common factor, and then we can actually start to factor by decomposition. It just makes it that much easier, and then we don't have to recognize an extra factor at the end of our question. So 4, 26, and 12, we can divide each of these by 2. Right? So let's go ahead and divide each of them by 2. We're left with 2x squared minus 13x plus 6. Now from here, we can take this trinomial. Leading coefficient's 2. So we need two numbers that multiply to 12 and add to negative 13. So 1 and 12 do that with a negative negative. Okay, so just bring this 2 down as a common factor. And now inside this bracket, we want to break down this middle term into negative 1x minus 12x. Okay, again, we're going to factor by grouping. Here are two groupings. So we bring down the 2, we still use the bracket, and what can we factor out of 2x squared minus 1x? Just an x. We're left with 2x minus 1. And what can we factor? We divide by that, that's fine. What can we factor out of negative 12x plus 6? Well, negative 6. And we're left with 2x minus 1. Okay, again, bring down that 2. Now, within this bracket, what's identical? The 2x minus 1. What's left over? X minus 6. And that's fully factored. Okay, last one. 4a squared plus 10a minus 6. Again, we can pull out a 2 here. So let's pull out a 2 first. we're left with 2a squared plus 5a minus 3. Now we can actually start to factor. Okay, leading coefficient is not 1, so we have to multiply 2 times negative 3. So what two numbers multiply to negative 6 and add to 5? Okay, well 1, 6, 2, 3. You have to add to 5, but one of them has to be negative because we have negative 6 here. Let's do this. Negative 1, 6. Okay, so let's break down that middle term. 2a squared minus a plus 6a minus 3. These two terms can be divided by a. These two terms can be divided by 2. And we're left with 2a minus 1 plus 2. And it's going to be 2a minus, oh, that's divided by 3. Now it's 2a minus 1. Okay, now I immediately knew that I was wrong because I was getting 3a and then like 3 divided by 2 didn't work. So now I know I'm correct because this bracket is identical to this bracket here. So 2 is still a factor, 2a minus 1 is a factor, and then a minus 3 is a factor. And that's done. Okay, so example 3, find two values of k so that this trinomial can be factored. Well, when I take a look at this, I recognize immediately that we can root 4x squared. I get 2x. And we can root 81. I get 9. So this middle term, we can turn this into a perfect square trinomial. We can have a factor multiplied by, or a binomial multiplied by itself, and it'll turn into that perfect square trinomial. We're going to basically have like a 4x squared plus 9, 4x squared plus 9. So to find this k term, we don't have to go through like the expansion. What we have to do is we just have to do 2 times 2x times 9. 2 times 2 is 4. 4 times 9 is 36. So that middle term is going to equal 36x. So k equals 36. Okay. If you want to see it formally, we could have put 2 times 2x times 9 is going to equal that middle term, which is kx. And these two x's balance, so they can go away. X equals 36. That's a 6. Sorry, k equals 36. The other number that it can be is negative 36. Let me explain this one. Okay, so if we have in these brackets 4x squared minus 9, 4x squared minus 9, what's going to happen is when these two are multiplied, they're still going to create positive 81. But this time, what we can do, and I'll just put this small right here, we can do 2 times 2x times negative 9. And we're going to get negative 36x this time. So k can also equal negative 36. There are two numbers that make this trinomial factorable.